Stoichiometry. Important concept is a mole. Mole is the base unit of amount of substance. It's the mass that contains 6.023 times 10 to the 23rd atoms of molecules of a substance. Atoms is for an element and molecules is for a compound. This number is called Avogadro's number. The exercises are like conversion of units. In this case, we have to convert how many moles are in those atoms. Okay, data is 9.35 times 10 to the 24th atoms. Item 1 atoms goes down. I want moles goes up. 1 mole has 6.023 times 10 to the 23rd, and we have to solve this. It's division. And this is 15.52 mole of arsenic. The second example is the same. Remember atoms because I have an element, in this case molecules because I have a compound, but the procedure is the same. My data, the 23rd molecules. Okay, and you want molecules, go down, I want mole, goes up, 1 mole, 6.023 times 10 to the 23rd, and just answer that. And this result is 0.53 moles of water. On the contrary, how many molecules are in those moles? Okay, my data is 0.87 moles of sodium chloride. I don't want mole, goes down, I want molecules, go up, 1 mole has 6.023 times 10 to the 23rd molecules, and we can cancel moles, and in this time we have to multiply this by this, and the result is 5.24 times 10 to the 23rd molecules of sodium chloride. The next example, I have atoms because we are talking about an element. And this is 2.75 moles of uranium times, I don't want mole, goes down, I want atoms, go up, 6.023 times 10 to the 23rd atoms, cancel mole, multiply, and the answer is 1.65 times 10 to the 24th molecules. No, sorry. Atoms of uranium. Next concept, molar mass. Molar mass is the mass of a mole of any substance. It's expressed in grams. For an element, it's its atomic mass. For a compound, it's the total sum of the atomic mass of the all elements in the compound. Okay, to solve it, we have to separate the elements in the compound. The first one is magnesium bromide. Okay, we have magnesium and bromine. Number of atoms, 1 for magnesium, 2 for bromine. And we have to multiply this by the atomic mass of the element. Remember, we have to round it. This is 24 times 1 is 24. Bromine is 79.9, means 80, times 2, 160. And if we add this, and the units are grams per mole. Second example, separate the elements, rubidium, carbon and oxygen. I have 2 atoms of rubidium, 1 of carbon, 3 for oxygen, and multiply by its atomic mass. Rubidium 85.4, it means 85 times 2, 170. Carbon is 12 times 1 is 12. Oxygen 16 times 3, 48, and add. 12 grams per mole. Bit more complicated. This is platinum, oxygen and hydrogen. 1 platinum, and this 4, remember, is multiplying oxygen and hydrogen, so I have 4 atoms in one. Look for the atomic mass is 195 times 1. Oxygen 16 times 4, 64, and hydrogen is 1 times 4. Okay, this is 8, 13, 10, 16, 2 grams per mole. And okay, last example. Let's separate the elements. We have nitrogen, hydrogen, phosphorus, and oxygen. This tiny 3 is multiplying those elements. So I have 3 atoms of nitrogen and 3 times 4, 12 atoms of hydrogen, 1 phosphorus and 3 oxygens. Okay, the atomic mass, nitrogen is 14 times 3, 42. Hydrogen is 1 times 12 times 1, 12. Phosphorus is 31 times 1, and oxygen is 16 times 4, it's 48. And add this 10, 13, 1, 5, 6, 10, 13 grams per mole. And that's it. Now, let's do problems with this. How many grams are in 3.7 moles of mercury dioxide? Okay. Every time ask me grams, I need to calculate molar mass. My formula is mercury dioxide. Let's calculate the molar mass. It's 1 of each element, Mercury is 101 and oxygen is 16. And 16 is 7, okay, grams per mole. To answer the problems, write the data, mole, and the conversion. This molar mass is the mass for 1 mole. Then 1 mole of this compound, mercury oxide, 1 mole is 217 grams. So cancel moles, and you have to multiply 3.7 times 217, and there is 802.9 grams of mercury oxide, and this is the result. Other example, this is by the contrary. There are me moles and my data are grams, but again, if I have grams or ask grams for me, I need to calculate the molar mass. Carbon dioxide. First of all, check that you are writing correct the formula. Carbon and oxygen, 1 and 2. Atomic mass, carbon is 12, oxygen 16, 632. So the molar mass are 44 grams per mole. Write the data. 280 grams of carbon dioxide by, I don't want grams, I want moles. 1 mole, 44 grams of carbon dioxide, grams are cancelled, and divide, and the result is 6.36 moles carbon dioxide. Little bit complicated. Grams to molecules. Okay, let's remember. In the first exercises, we saw that a mole has 6.023 times to the 23rd molecules, but I have grams and molecules. There's not straight way, so I have to change first 2 moles and then 2 grams. And 1 mole is equal to the molar mass in grams. So we have to calculate first the molar mass. Silver nitrate. Silver nitrate. Remember, silver has oxidation number of 1, nitrate -1, so this is the formula. Separate the elements, silver, nitrogen, and oxygen. 1 atom of silver, 1 for nitrogen, 3 for oxygen. Silver is 108. Nitrogen is 14, oxygen 16. Multiply and add. Plus 14 plus 48, 170 grams per mole. Okay, let's split time. My data, 7.09 times 10 to the 22 molecules. Okay. I don't want molecules, so goes down. 6.023 times 10 to the 23rd molecules is 1 mole. Cancel molecules, and we have Um, 170 mole of silver nitrate, but I don't want moles, I want grams. So we have to do another conversion. 70 moles by 1 mole, 170 grams. Cancel moles, and this times 170. My final result, it's 20.01 grams of silver nitrate. And that's it. Okay, another type of example. How many grams of selenium are in 500 grams of lead-2 selenide? First of all, we have to write the formula. Lead-2 selenide is lead selenide. This is 2, selenide is -2, so this is the formula. Let's calculate molar mass. Lead is 207 grams and selenium 79. Add this, and this is my molar mass, grams per minute. Okay, my data is 500 grams of lead-2 selenide, and this is the molar mass of the whole compound. Okay, we have 26 grams of lead selenide. In these grams, I have this quantity of only lead. Oh, but we asked me, and those are for selenium. So, in these 286 grams of the whole compound, 79 grams are for selenium. And we have to cancel grams of the compound and solve it. Multiply the ups and divide it by the molar mass. It's my result. Grams of selenium. And that's it. Okay. When I have compounds like gases, there is a standard temperature and pressure is a condition. It's important that in the formula, in the problem, is STP, standard temperature and pressure. And we have constant, then a mole of any gas occupies a volume equal to 22 times 0.4 liters. In this example, calculate the volume of 0.46 mole of hydrogen, 0.46 mole of hydrogen by, I don't want mole, I want liters. And we're gonna use this factor, 1 mole, 22.4 liters, and just have to multiply 0.46 times 22.4, and this is 10.3 liters. Cancel total moles, and this is the